This is our agenda which we are going to cover in this session. Introduction to Neural Network Toolbox, workflow for designing neural networks, what is deep learning, introduction to fuzzy logic, what can fuzzy logic toolbox software can do, fuzzy foundation of fuzzy logic, neuro adaptive learning, and ANFIS also we are going to see. Okay, so first we'll start from fuzzy logic designing. So first of all we'll understand that what is the fuzzy logic basically. Okay, once we get that what is fuzzy logic and how it works, then further we will see how to design the fuzzy logic using MATLAB. Okay, so this is agenda for fuzzy logic. Introduction to fuzzy logic, what can fuzzy logic toolbox software can do. Already we discussed this agenda, right? So let's start from some applications of fuzzy logic. So lots of applications of fuzzy logic. Fuzzy logic you can use as a data analytics part, means taking some decisions based on the fuzzy logic model, or you can use fuzzy logic as a controller also. So like in washing machine there is a fuzzy switch, right? So automatically it measures the clothes and automatically it tune the time and everything, it works automatically. Some applications are like this, like classify pixels using fuzzy system. Let's say that you have to classify some vegetable, some flower, some grass, that what kind of pixel values are there, what kind of fruits are there, right? In agriculture also fuzzy logic is very widely used. Autonomous parking using fuzzy inference system, modeling traffic patterns using subtractive clustering. So if you have to monitor the traffic patterns, that there also you can use fuzzy logic. Or if I am talking about temperature control in a shower, there we can use it. Or if I am talking about power system, then you can use fuzzy logic controller in inverters to control the output, right? So lots of applications are there fuzzy logic. But the question is that when you are going to use the fuzzy logic and when you are going to use the neural network. So fuzzy logic is totally based on the human reasoning. Even if you have data, if you don't have data, if you know the logic, you can create the some rules and you can design the fuzzy logic. But in neural network we require a complete data set to design a model. So the work is the working is same. I mean the output which you want, it that is the somehow same. Like we are going to create some kind of predictive model, it will predict for me or it will control something. Same thing neural network will do, it will predict or forecast, or it will control something. As a controller also you can use it. So how you can use how you can design the neuro fuzzy, that also we will discuss in this case. So let's start from the basics, that what is fuzzy logic. Fuzzy logic is all about the relative importance of precision. How important is it to be exactly right when a rough answer will do? A simple rough answer, let's say that I am a farmer and I am saying that okay, temperature is this today and humid is this today, then rain will be there or not? Something logical, rough answer, that if I am farmer I can say that okay, temperature is this, humid is it, then there is a possibility of the rain. Some kind of rules I am taking the decision. So fuzzy logic is a old and new as well. So lots of modification is still required. That's why it is new. And why it is old? Because it is old people skills. So you don't require any kind of things to know. If your logic is good, if your reasoning is good, then you can design a fuzzy logic. So in this sense, the fuzzy logic is both old and new, because although the modern and methodical science of fuzzy logic is still young, the concept of fuzzy logic relies on age-old skills of human reasoning. That's all. So long ago, fuzzy logic was developed, and that time we didn't have a lot of sensors, we didn't have data. So based on the reasoning, they were able to design this kind of models. I mean, even if you don't have data. See this example. Let's say that something is falling, so falling on someone's head, and two answers can be there, right? One, precision, another is significance. Precision is like that I can say, hey, 1500 kg mass is approaching your head at the speed of this. But what is this? Just I am telling that okay, it is falling, this is the speed, this is the mass. But what is the significance of that? Look out, otherwise you will be smashed, right? So these two things, when we combine it, that is called the fuzzy logic, and fuzzy logic is more about significance. Okay, that what thing is going to happen. Like if I have to predict the consumption of energy, consumption of power. So let's say that I will make some rules like that. If temperature is low and humid is high, then today consumption of energy will be this: medium, normal, or high, something like that, right? How it work? We will have some input space, and we'll have some output here, and here it will be like a black box. We'll create some rules based on the input and outputs, and we'll fuzzy logic will be trained, and it will give me example. Let me show you one example first of fuzzy logic, an input output map for the tipping problem. So what I'm going to do here in MATLAB, I'm going to switch here, and later we'll see how to design also. So I'm going to load that fuzzy inference system. Okay, just wait. This is already designed service and tipper based application it is. Okay. Now to open the fuzzy logic, just I will go in application, or simply I can type from here also fuzzy logic designer, and app will be opened. So I have this tipper problem. Let me explain that, then we'll go further how to do this stuff. So what I'm going to do, which is already designed, I'm going to export from workspace, and the name of this is A. So in this case, you see that we have some services. Let's say I am going to a restaurant. Based on the service and the quality of food, we have to give some tips, right? So here you see, if I click here in the role, see, if service is 5, if food quality is 5, then tip will be $15 or 15 rupees. So let's say that I am going to increase the service, increase the food quality, and you see that tip is increased. So this is the defuzzification. So we are going to see this kind of complete model, how we can design, right? So if you see that if I decrease the service, tip will be decreased, right? From fuzzification to defuzzification. Okay. And what kind of rules are there? If I click here, here rules, how do we make rules? You see that 3 rules are there. If service is poor, food is rancid, means bad, then the tip is cheap. If service is good, then tip is average. If service is excellent or food is delicious, then tip is generous. So like this we create some rules. And how we make rules? From here, let's say that if service is excellent and I want food is none, then tip will be generous, and simply we will add this rule here like this. So you see that 4 rules right now we have, right? And if I have to check the variation, I will go in view, I will click on the surface plot, and I can check the variations also, that how it's vary, right? On sorry, on x-axis we have service, on y-axis we have food, and on z-axis we have tips. So your variations would be like this, not a constant or unvaried kind of things. Okay, so I am going to switch here. Okay, so we'll have some input space and we'll have output space, and it is a kind of black box. We don't know what is going on inside, and it will create a model. Then we can do some kind of predict, and we can do some kind of decisions. We can take decision based on that. So why use fuzzy logic? Fuzzy logic is conceptually easy to understand. Fuzzy logic is flexible. Why it is flexible? Depends on you, that what kind of rule are you going to make. Fuzzy logic is tolerant for imprecise data. If you have a imprecise data, fuzzy logic is tolerant, because again it depends on your reasoning. You don't require accurate data for that. Even if your data is imprecise, you can go for the fuzzy logic. Fuzzy logic can model non-linear functions of arbitrary complexity. So if you have non-linear functions or complexity is more, then you can go for fuzzy logic. Fuzzy logic can be built on top of the experience of experts. Fuzzy logic can be blended with conventional control techniques. Fuzzy logic is based on natural language. So some simple natural language, that is human language, right? So you can create what you can do with the fuzzy logic toolbox in MATLAB. You can create and edit fuzzy inference system with fuzzy logic toolbox software. You can create these systems using graphical tools or command line functions. So two options you have. You can use the app to design a fuzzy logic FIS system, or you can write a code for it. Command line functions are available. So both I will show you how to do. You can generate them automatically using either clustering or adaptive neurofuzzy techniques. So you can use adaptive neurofuzzy logics also, techniques also, and you can generate this kind of models as well. Also, if you have access to Simulink software, you can easily test your fuzzy system in a block diagram simulation environment also. So instead of writing a code, instead of using the apps, you can use Simulink also to design a fuzzy logic. This toolbox also lets you run your own standalone C program directly. So you can convert in a C program also, you can deploy in a controller as a controller, as well as you can create a .exe file also from there. Now foundation of fuzzy logic. So how it works? The point of fuzzy logic is to map an input space to an output space, and the primary mechanism for doing this is a list of if and then statement called rules. All rules are evaluated in a parallel and the order of the rules is unimportant. So order doesn't matter here. We will have some inputs, we will have some outputs. Based on the input and outputs, we make some rules. Like if in the case of service and tips, if service is this, food is this, then my tip is this. I am using and, or I can use or also. If service is this, or if service is excellent, if food is good, then tip is this. So and or if conditions we use in this, if and then. Okay, something like that. In this case, the example which we saw just now, if service is poor, then tip is cheap. If service is good, then tip is average. If service is excellent, then tip is generous. Something like that. Now fuzzy sets. So see, if I am talking about general simple logical system, if I have to extract the days of the week, so in this data, this sets which you see here right now, this one, simple logical system, I will, if I ask you that what is the days of the week, you will say Monday, Thursday and Saturday. Of course, liberty is not a days of the week. Shoes polish is not a days of the week. So this is the exactly, this is a crisp value which we say. So simple logical system which you study, it is based on the crisp data. Okay. If I am talking about fuzzy logic, in fuzzy logic, Friday is also somehow weekend. So in fuzzy logic, the truth of any statement becomes a matter of degree. Means at what degree Friday is the days of the weekend. Okay. Here's the days of the week we was talking, days of the weekend. So simply if I am talking crisp value, then what will you say? Saturday and Sunday both are weekend, right? But fuzzy logic says no. There is some degree. Friday is also somehow, Friday will also come in somehow in the weekend and in weekdays as well. So this is very important when you are going to make the fuzzy logic inference system. Okay, so you have to take the some intersection points also from there. Saturday, Sunday, okay, that is fine, but I am saying Friday is also with some degree it is the weekend. Like these fuzzy sets work. So there is some values between 0 to 1. Maybe Friday is 0.4. 0.4 is as a weekend and 0.6 as a weekdays, something like that. Okay. If I am talking about a simple logic system, crisp value, days of the weekend, two valued membership only it will be. Either it will be 0 or 1. Let's say that for weekdays, I am saying I assign the value 0, and for the weekend, I assign the value 1. So if I am talking about Thursday, then it will be 0, Friday 0, Saturday 1, Sunday 1, because they are weekends. Monday is again 0. That's the simple sets which I am talking about. Okay. Now if I am talking about fuzzy sets, days of the weekend, multi-valued membership it will be. Thursday, see that there is some amount of degree, right? So Thursday is not exactly 0. There will be some value between 0.0 to 1. Friday as well, Saturday, Sunday and Monday, let's say that it is completely 0. So there will be some values will be assigned between 0 to, but in the simple logic system, we will have either 0 or 1. So in this case, your graph will look like this, right? It's a square wave kind of thing, 0 or 1. 0 means weekdays and 1 means weekends. If I am talking about fuzzy logic, the graph will look like this. Somehow it will be curved, not a exactly square wave. So this is also called a membership functions also. So that how we are converting data set inputs in a membership function of the fuzzy logic system. So it will vary like this, right? Hope that you got that what is difference between simple logic system and the fuzzy sets. Okay. So this what we do here, if I am talking about spring and some other seasons. So spring, let's say it is 1, summer is 0, right? Fall is 0, winter is 0. In this case, you see that this is a curve, not an exact square pulse wave kind of things, right? So now about the membership function. What is membership function? A membership function is a curve that defines how each point in the input space is mapped to a membership value or degree of membership. So we will have a crisp value first of all as an input. Let's say if I am talking about temperature, so what will be a value we will have, like 18 degree Celsius, 20 degrees Celsius, 30 degrees Celsius, 40 degree it can be, right? So what we do, whatever inputs we have, we map with the membership value, means, or we can say a degree of membership, that at what degree it is high temperature, at what degree it is low temperature, or at what degree it is medium temperature, something like that. Depends on you that how you are going to do a grouping. I can do a low, normal, high, or I can do low, medium, normal, high, very high. Okay, between 0 to 1, the input space is sometimes referred to as the universe of discourse, a fancy name for a simple concept that is called actually. So here you see. Now again, if I am talking about simple logic sets, if I am talking about that if a person is tall or short. So if I am talking if a person is tall or short is simple logic system. So I will assign, if it is short then I will give the value 0, and if he is short then I will assign the value 0. If it is tall then I will assign the value 1, right? But if I am talking about fuzzy set, let's say that if a boy is aged as a 6 years old and he is 3 feet, he will be also tall according this age, right? And in the simple logic system, if I am talking, let's say that who is above 5 feet he is tall and below 5 feet he is short. So above 5 feet 1 value and below 0, but not in the case of fuzzy logic. So fuzzy logic will where the graph will vary like this, not only 0 or 1, there will be some degree between 0 to 1. It can be 0.6, it can be 0.4, it can be anything, it can be any value, it can be 0 to 1. So the curve which we make between 0 to 0.1, that is called the membership function again. Okay, so this is a continuous membership function for the tall, that at what degree the person is tall or short, something like that. So fuzzy set describe the vague concepts: fast runner, hot weather, weekend days, as we discussed. A fuzzy set admits the possibility of partial membership in it. Partial means it can be a weekend or it can be a weekdays also. Friday is a sort of a weekend day. The weather is a rather hot, something like that, right? So it is, there is a vague and there is a partial membership kind of things. The degree an object belongs to a fuzzy set is denoted by a membership values between 0 and 1. Means the mapping from crisp value in a fuzzy set, the mapping which we do, the output which we get, that will be a between 0 to 1, and the curve which we get, that is called the membership function. So a membership function here associated with a given fuzzy set maps an input value to its appropriate membership value, that is between 0 to 1 again. Now about operators, how operators work. When we make the rules, we apply some kind of operators. So you see that you know about AND or not, 0 0 0 for AND, right? 0 1 0 again, 1 0 0 1 1 1. In this case you see 0 for OR 0 0 0 0 1 0 1 1 0 1 1 1 1, and not just inverse that, 0 will become 1 as output, 1 will become 0. These are normal logical operators which I am talking about. In fuzzy logic, we don't multiply. In this case, in the AND case, we don't take the max value, I mean the numeric value in this case. Here we apply like this: if there is AND, if I am saying if food is bad and I use the AND, if food is bad and service is good, so what will I do? I will take the minimum value. Food is bad, the food will have some minimum value between 0 to 1, right? So here we take the minimum value when I am saying AND. If I am saying OR, I am saying if food is excellent, if food is delicious or service is excellent, in that case I will take the maximum value as output from there. Okay, we are applying operators on the fuzzy set. Okay, so in the, if in your rule there is an AND, you are going to take the minimum value. If in your rules there is OR operator is used, then you are going to take the maximum value. About NOT, if I am saying if food is delicious and service is not good, if food is delicious and service is not good, in that case we will subtract from 1. Whatever value we will have for service between 0 to 1, we will subtract by 1. That will be output. Okay, if then rules will work like this, as I told. If service is excellent, let's say that value is 0. Food is delicious, let's say 0.7. So here if I am using AND, so here you see in this the value of excellence is 0 and the value of delicious is 0.7. I am using let's say I am using OR. If service is excellent or food is delicious, right? So here you see that the rule which shows here, that is if service is excellent or food is delicious. So what will be output? Max value. In the case of OR, that will be 0.7. Perfect. So it works like this. If OR is there, then we will take the max value, else we will take, in case of AND we will take, in the case of OR we will take max value, in the case of AND we will take the minimum value. Fuzzy inference process, how it work? So like this it will work. In the case of service food example which I showed you, first of all we will have some values for the service between 0 to 10. We have to assign. In the case of temperature, let's say that minimum value is 2 and maximum value is 50. So in the case of temperature it will become 2 to 50. So in the case of service, let's say it is between 0 to 10 and the food input value is 0 to 10. So then we make some rules. First of all, we will assign that service is poor, good, excellent. We group that based on the data, this data between 0 to 10 for the food as well. And further, we make multiple rules. Depends on you how many rules are you going to make. The variation should be good. I will show you what is the variation again. then we take the summation of that, and here is the output between, let's say that tip I am going to give between 5% to 25%. That is the final output. The inputs are crisp, that is non-fuzzy, numbers limited to a specific range. All rules are evaluated in parallel using fuzzy reasoning. The result of the rules are combined and distilled, means defuzzified. The result is a crisp. Again the result, the output after defuzzification, you will get the crisp value again as a numeric value. Okay, fuzzy inputs. So here we will have some inputs. Let's say that some inputs I have between 0 to 10, and if some food is delicious, let's say value is 8. What will happen? It will be normalized. I mean, it will be converted as a membership sets, fuzzy sets. Let's say that 8 is equal to 0.7. So you don't have to do this. Fuzzy logic toolbox will do for you for that automatically. Okay. Instead of OR, you can use prob OR also. I told you you have to take the max value, or you can take like this also. Whatever values are there, 3, 8. Let's say the value is 7. 0.7 plus 0.0 minus a into b. Again you will get 0.7 in this case. Let's say that service value was 1 here. So what will be the output? 7 plus 1, that is 8, minus 1. Again you will get the value 7. So a plus b minus ab also you can use instead of or. So this is called, then next step is to apply the implication method. Implication always we also call this as an antecedent. And when we make a relationship between inputs, we say it antecedent. When we make relationship between input and output, we say it consequent. What is the consequent of that inputs? Okay. So here it looks like this. Just wait a minute. If service is excellent or food is delicious, so in this case we will apply a implication. So service is excellent or food is delicious. We will take the max value from here. Perfect. Then we apply a implication. For implication, always you will take the mean value. Okay, after applying after implication here, let me show you. After applying the implication here, what we are getting? 0.7. Wait. 0.7. Okay, we got the output. Now tips will have between value 0 to 25, or let's say 10 to 25. Okay, it will have also some value, and this value will be again normalized between 0 to 1. I mean fuzzification of that between 0 to 1. Tips 0.7 we are going to apply with the output. In this case always we take mean value. Let's say that between 0 to 1 tips value is coming 0.5. So 0.7, 0.5, what will be a minimum value? 0.5. 0.5 will be output in this case in the fuzzy sets. So antecedent after implication, we apply implication with the consequent, means the output. In this case we have a tips, so final will be a minimum value, that will be 0.5. Perfect. Like this we make multiple rules. Service is poor or food is rancid. Service is good, then tip is average. If service is excellent or food is delicious, then tip is generous. So like this we will have a multiple rules. So again here we will apply, depends on the and I am using or I am using. Or I am using, I will take max value. If I am using or and I am using, then I will take the mean value. Okay, then we do a implication with the output. Here always we will take the mean value, and this will be my final graph. Second, final, and then further aggregation of all the rules. That is the aggregation, last one. Okay. For defuzzification, this is the aggregation one. This one which I was talking here below. Let me zoom it and show you. Just 1 minute. Okay, this which I was talking, this one. this one. So what will be, how to defuzzify this? If I am giving some inputs, then how we can do a defuzzification of that? So there are different methods. One method is a centroid method. Whatever centroid value will come from this, that will be a final output. Whatever I am food type, whatever is the service type, in that case, let's say that tip is the 16.7% I am going to give. So centroid, there are different other methods. Bisector method is there, some other methods are there. In this case, that is the centroid method. This is the fuzzy inference diagram. It looks like this. Apply operators between inputs, then if it is it, and then what is the output, implication, then multiple rules, and at last we will have defuzzification of that. So multiple loops, we saw how the inference system will look like. So you can have a multiple rules as well. Now fuzzy as non-fuzzy logic, fuzzy and non-fuzzy. So let's say that non-fuzzy approach for the same thing. What I am doing here, begin with the simplest possible relationship. Suppose that the tip always equal to 15%. Okay, whatever tips is there, whatever service is there, tip will be always 15%. So in this case, what we will get? A linear line, right? This is the equation for that. But here we don't have so much variation. 15% is fixed. Why should I pay the 50% all the time if food is even bad, right? This is the question here. More variation we can do. We can add the service plus food both. So we'll get some 3D graphs. So how this tip is varying on the y-axis. It shows like this. For even if I am not happy with that, I can use some if-else conditions also in this case. If service is smaller than 3, tip is this, or else service is there 7, then tip is this. If service is smaller than equal to 10, then tip will be this. So in this case, we will get this kind of graphs. But still, I don't have any variation in this one, right? So multiple ways you can apply as a non-fuzzy. But in fuzzy one, how it will vary? It will vary like this. Your variation will be like this. Means for the every value of food, for every value of the service, your tip is changing. That is a more variation. So what we require basically, the more variation as our output. Fine. Okay, let's design a fuzzy logic. Then we'll see the neuro adaptive learning and ANFIS, that what is ANFIS. How fuzzy logic works first of all. So first of all, graphical way I am going to show you how to design this. Let's say that I have irrigation data here. I am going to open that first of all, the data which I have here. Soil moisture I have data, sensor from soil moisture sensor, relative humidity data I have, and temperature data I have here. Okay, based on this data I have water valve output. Means if soil moisture is this, relative humidity is this, temperature is this, then how much water valve I am going to open, means to feed water to the field based on the soil moisture, based on the relative humidity, and based on the temperature. Okay, this data we have. You have to use your logic to design the rules. Okay, so first of all, what we will do here, our first step is to provide some to divide this data as a group. Means let's say that soil moisture is from 0 to 6 to 20, it is low, 20 to 40 it is medium, and something like that it is high. We do a grouping of that. Okay, so to do this very easily in MATLAB you can do a grouping of your data. Let me show you how you can do, and later we'll discuss how to design. So let's say discretize is a function in MATLAB. Let's say that 1 to 15 I assigned as a dry soil moisture, 15 to 30 normal, 30 to 45 as a wet, and 40 to 60 as a saturated. What it will do, automatically this value will be assigned as a group. And once you, and you know that how to import data in MATLAB, right? Already we discussed that. Again, this function for the relative humidity, 0 to 15 I am giving as a low group, and 15 to 30 I am giving as a medium, and 30 to 60 I am giving as a normal, and 60 to 90 as a high. Depends on you how many groups do you want. Once you execute this, after discretizing, we are converting as a table in a single table by table command. Whatever variables name you have, you can convert as a table. Let me switch here, and let me open that table which I created from here. Where is that table? Let me check what is the table. Water wall C. Just wait a minute. So here is the, see, here we are converting here as a table, right? That is Eric table, something name is there which I provided. So let me open that table. See, grouping is done here by using that function. So you see that soil moisture is weight, and relative humidity is normal, and temperature is normal. How much water wall will be opened, right? If if soil moisture is normal, if relative humidity is low, temperature is medium, then how much wall will be opened? So these things you can do very simply by using this function discretize. Okay, and you require this data to import in MATLAB. And again, if you want to write in Excel file as a table, use the write table command. This is the data which you are going to write, and in which Excel file are you going to write, the Excel file name. Perfect. So once you run this, and I will have that Excel file here also, so I can save it in the Excel file as well. See, here we have this. Now we are going to make a FIS. So from here, that is a part of a control, and here you can search fuzzy logic designer, this one. I am going to open this. First of all, first step is how many inputs do you have? In our case, we have 3 inputs: soil moisture, relative humidity, and temperature. Perfect. So what will I do? I will go in edit, add the variable input. So 3 input first of all I will add here. So multiple inputs, multiple outputs, you can add it. How many outputs do we have? We have a water wall. How much percentage water wall we are going to open in the form, in the terms of percentage, 10%, 50%. Only one output we have as a water wall C, right? So now, first of all, we added the input here. I will not show you the complete design, but this way you can do it. Okay. So first of all, I am going to click this one, and just wait a minute. I am selecting this. I am going to name this. So let's say that I am going to give the name there soil moisture here. Just name the input. Okay, so short name I just gave the soil moisture for this. Okay, this is the first name. It is renamed here as a soil moisture. Second, let's say that it is relative humidity, humid. So here I provided the name for this also. And the last one is temperature in degree centigrade. Let's say that this is temperature. Done. Now output. What is output? Water valve opening. Fine. So we name that. First of all, depends on you how many inputs you have, how many outputs you have. You can go here in edit, and from here you can add inputs and outputs. Okay. Next step is membership functions. That membership functions will depend how many groups do you have for every input and output. So we can check it. 4 groups we have for everyone: dry, normal, wet, saturated for soil, and for relative humidity, low, medium, normal, high. Like this grouping we have. So 4 membership functions we require for inputs, and for outputs we have 5 groups: 1, 2, 3, 4, 5. So 5 membership functions we require for the outputs. So let's do it. So first of all, soil moisture. So there are different membership functions. You can select anyone. So first thing what I am going to do, I am going here and I am going to remove all membership functions. So we don't have any membership functions. I am going to edit. I am going to add membership functions. From here, different total around 11 membership functions are there. You can select anyone. I am going to select triangular membership functions. So triangular will solve mostly all the problems if you have. So membership functions, you got that how your data is distributed and how you are going to map that with the function. That's the membership function generally. Okay, number of membership functions in this case 4. Done. And you see here, you don't have to do anything. Just name the membership function name here. Group name. The first group name is, let me switch here and check, that is dry. So simply I will write dry. Second is normal. Select third membership function, third group. It is saturated, no, wet. And last one, let's say it is saturated. One thing more we have to do here, we have to provide here range. What is the range of that this soil moisture? So you can find out the max and mean value. So very simple, by giving the max and mean value function in the MATLAB. So here we have here relative humidity here. Okay, so if I extend this like this, let me extend this, just right click, mean value, and I want the max value. So simply select here what is the max value. The option is there. Yes, there is max value. So for the soil moisture, you see that mean value is 3, max value is 58. I will go here and I will provide mean value is 3 and max value is 58. Perfect. So like this we design. And now if you want to move this graph, you can move this also, depends on you, that how you are going to design. Okay, this is the for the first. As I told, we have to take the some intersection points also. As I told that Friday can be a weekend day and weekdays as well, right? So it is start from the -15. Depends on you. You can start from 0 also if you want. But I will suggest leave it as a group, automatic grouping here. You can make it 0. If you make this 0, then your graph will be changed. You see that now it's coming from here, right? Here, this one. If I do as a 0. See that this graph is changed. So some points we got here. So you don't have to do anything. Okay, this is done. This is done. This is done. And this, the 4 group we designed: dry, normal, wet, and saturated. This soil moisture is done. Now about the relative humidity. So again, what will I do? I will go in edit. I will remove, and again I am going to add membership functions. So what it is mapping. The crisp inputs are mapping with the membership function. So automatically it will be mapped. So I am going to use Gaussian membership function. I am going to use, and total the parameters, I mean the group which we have, that is 4: low, medium, normal, and high. So I am going here. Okay, it is still running here. So I am going to take 4. Okay, something is still executing. Just wait a minute for that. Okay, you got the idea that how do you have to design all this, right? This membership, same thing you will do for the water valve also. So I'm not going to design everything. Just I'm going to close this, and I'm going to open the already which I have designed. Fine. So already I have designed and I have saved this. Let me open that. Let me clear everything first of all. From here. I am going to read here FIS, and I will show you that how you can export from here, that also you can do it. So let's say that I am going to read here, and we use read FIS to read FIS file. So you have to provide the full name. Perfect. Okay, there is some issues. I think there is some errors. Let me check that again. Let me drag it here. So it is still opening. Okay. Let me read this again. So you see that here all informations are given here. What kind of rules are there, how it is made, and you can drag it and you can check it also from here. So what I am going to do here, which I have already designed, I am going to open in that fuzzy logic designer. So from here I can open the fuzzy logic designer, and I will go in file, I will go in import from file, and from here I am going to select this. So it is still opening. It's taking time. Okay, just wait a minute now. It's taking time little bit. Let me close this MATLAB and open it again. Maybe some issues occurs there. So I'm going to open this again after closing that. Okay, later while it is opening, let me discuss about neuro-adaptive fuzzy learning and ANFIS. So FIS structure, we discussed that what is the FIS, fuzzy inference system. So we can use using ANFIS training method, you can train Suzuno system with the following properties. So two kind of models we can design in MATLAB. One is Memedino and other is this is Suzuno system. So in Suzuno system, the difference between is that in Suzuno system we provide the weight also for the every inputs. If you want, you can provide the weight as well for that. Okay, so let me switch here in MATLAB again. Just wait a minute, let me open the MATLAB again. Okay, it is opening. Now about a neurofuzzy designer. So the neurofuzzy designer apps lets you design, train and test the adaptive neurofuzzy inference system, that is called ANFIS, using input and output training data. So in this case, you don't have to define the rules as well. So you can use the neurofuzzy designer to create a ANFIS system. So automatically it will train fuzzy as well as neural both together, and we will have a predictive model. So we'll see this one also, how to design this. Let me check if MATLAB is opened or not first, then we will discuss about that one. Okay, just wait a minute. Okay, here we have. So let me open the fuzzy logic designer from here again. So meanwhile, if you have any questions, you can ask. So we saw that what is the basically fuzzy logic designer, what is fuzzy set, or what is a simple logic system. Further we saw in app that how to design, and further we will see more how to create a rules in this case. So first of all, let me load that, then we will discuss. From file, this is FIS. Okay, some issues are there, it is not loading. Just wait a minute. Just wait a minute. Okay, now we have here in workspace, finally it's works. So some issues were there, I think. So a is equal to read fish, and this is the FIS file which we have right now here. Okay, now again I am going to open that tab, and I am going to import from workspace, and the name is as a again it's coming like this. No, not this one, just wait. Okay, let me define it again. Let me tell you how to do it again. Okay, what I am going to do, simply I am going to add some inputs here. Let's say in our case we had the 3 inputs from file from edit, and I am going to add one more inputs. Okay, the first step already we told what is the name of here. You have to define it. Let's say this is soil moisture, and second one, let's say it was humid, and third one was it was temperature. Fine. Then next step is just double click on this, add the membership functions. So in our case, let's say I am going to take 3 only. I am going to take for this dry. Second one I am going to take as a wet, and third one I am going to assign as a saturate. Okay, so like this we have to define it. Once you have done this, just provide the mean and max value of your data. Let's say mean is 3 and max value is 56 in this case. And after doing this, just it is designed, then go for the humid also. Same thing you have to do. Let's say humid is low, and second is normal, and let's say third is high. And nothing you have to do in this case. Again, the mean humid value and max value you have to provide. Let's say it is 20 to 90 humid value we have. So same way we are doing here. So instead of using 4 or 5 membership functions, this membership function depends on the group, how many groups do you have here. Okay, so I am taking the default 3 only, or from here you can add the more membership functions here based on the group, how many groupings you have done there. For the temperature also, let's say that temperature mean value vary from 5 degree to 50 degree centigrade. Perfect. And let's say that first is coming in the low, and second is coming in the medium, and third is coming as a high. I think this was not importing because I designed in the previous version of MATLAB. That's why in the latest version it is not able to display there. So no problem. Okay, so like this event. Now for the output. So our output was the valve opening in our case. So just double click on this, and we have this output. Let's say the valve opening is minimum here value is from 20% to 100%. Done. And the name here we have to provide the name for the first group. Let's say that the opening is in this case low. This one, let's say it is medium, and this one is comes here full, something like that. So based on the group you have to design it. Once you have designed everything, we make the rule. Okay, so what we will do, we will go here in edit. Fine, there is the option here, rules. Now you have to make the rules from here. Let's say that it depends on your reasoning again. Let's say if I am saying if soil moisture is dry and humid is low, temperature is high, I want to open the full, that valve, water valve which is there. After selecting this, you have to add this rule like this, and you see that this rule will be added here. If I am saying if soil moisture is saturated and humid is also high, the output opening will be low. Of course, soil moisture is saturated and humid is high, then we don't require so much water in the field, right? Then click here, add the rule. You see that second rule is added here, right? Same way, if soil moisture is high and humid is normal and temperature is medium, then I will open the valve medium somewhere like this. Once, so like this you can make a multiple rules, but you have to remember, don't make the repeated rules. Or the other way, already I told, you can use discretize function and you can create it like this, just we have done here, and from here you can check that if soil moisture is wet, it is normal, and temperature is normal, then valve opening is coming in which group. Okay, so he, instead of providing a numeric value, I just provided the low, medium, high, in full in that case. Okay, once your rule is done here, what next step is, what, go in view, check the variation. So you see that in this case variation is coming flat. So you have to add the more rules to make these variations more. So once you have done this variation, go in rules, and when you move this, and this output is, you see that defuzzified, right? Defuzzified here. Just move this and this value will be changed from here. So like this. In this case we have a less rule, so this value is not changing. So otherwise you can make the multiple rules in this case, then this value, you will see the variations there in that case. Fine. Okay, once you have done this, there is an option to export. To files you can export, or you can export to the workspace. Just give the name. Let's say that this name is, as I am giving, as a YMCA, and when I click here, I will have this YMCA here. Perfect. And here what is AND method, OR method, implication method, aggregation method, these things you can change from here. What AND method are you going to use, what OR method are you going to use, what implication method are you going to use, what aggregation method, and defuzzification. I told there is a centroid bisector. As a default it will be like this. Okay, once you have this here as a YMCA, now if you have to apply your new data, what will you do? We use evalFish command. evalFish, in bracket, the model name, in our case the model name is YMCA, comma, and we will provide the 3 inputs, right? First of all is soil moisture, then humid, and then temperature, and it will give you the output, that is the 60%. I have to open that valve. Perfect. So like this you can design this any kind of fuzzy system. Okay, next if you have to write a code for that, by writing a functions, how you can design that kind of fuzzy logics. That's a bit complicated, but if you are a beginner you can start by apps. So first of all, let's say that I have to design one fuzzy model to detect the age from this image. So simply read the image, display the image, next is convert in the form of gray, and further depends that what kind of data you have. The important thing is that how to add the rule there, right? So this convolution of this image, further convoluted to get the gradient of that image. Once we have this gradient, so we have 2 inputs, one is IX, another is IY. So like this we create a fuzzy logic. First of all, Memedani we are using, MAMFIS. What is the name of this fuzzy inference system? Then how to add the inputs. This is the way how we are going to add the inputs. In age FIS we are adding what is the minimum and maximum value, what is the name of that. Second input we will add like this, age FIS, what is the minimum value, maximum value, and what is the name of that. Okay, then add the membership function, add MF in age FIS again, and this is a Gaussian membership function with standard deviation and mean value. Mean is 0. Okay, so like this you can create a complete fuzzy inference system. Then add the output like this. Once you have added, add the membership functions for the output also. Here triangular membership function is there, which we are designing just before, right? And you can plot it like this, different plots, and once rule you will add like this. if x, you have to write in a double quote, if ix is 0 and iy is 0, then I out is white. If ix is not 0 or iy is not 0, then output is black. Add the rules. Once you have the add the rules, your FIS system is ready, and further you can predict it as you want. Same way in the app which we have done right now, right? Okay, let me close this one. Okay, import from files. This is the service and food one. This is my FIS file, that is service and food one. Okay, we got this, how to design this. One thing is important, when you design your model, your variation should look like this. Depends that what kind of data you have. It has to be vary, it has not to be flat. So for every data it has to be vary like this. Okay, perfect. So I am going to close this, and we will see ANFIS how to design. So I am going to switch here. We were discussing that how to design a neurofuzzy designer, so we are going to talk about ANFIS, how to design it. So in this case we require a data. Okay, in this case we require a data. Let me switch here and clear everything, and let me open the data. First of all, I am going to load the data which I have here, and you can use open the neurofuzzy designer from you can go in the app. This is a part of a control system. So here you see we have a neurofuzzy designer. Okay, just open it from there, and the data which I have, you see that we have two data. One is for the training, another is for the testing data. So we have two data here. 25 into 2 means if I double click on this, I have this input. You will have multiple inputs also, and this is the output in this case. Okay, this is for the training, and this is for the testing. We are going to test on this data or check the data inputs and outputs. Okay, so first of all we have to open that app. So here is the app. So in the app, first of all you have an option. Are you going to load training data, testing data, or checking data, or demo? Some demos already if you have. So first of all our step is to load the training data. So what is the training data name here? This is the training data name. Right click, rename it, and I am going to add this training data, and I will go here and I will click here load data. Not from here. I am going to load from workspace, and I am just copy pasting, and we will have here this training. This data we are going to train. On x-axis we have inputs, on y-axis we have outputs. Now next I am going to load the checking data where we will test it. So here just click this here checking data, and what is the name of the checking data? Just copy it from here. So I will rename and just I will copy directly from here. Okay, from workspace load that checking data as well. Perfect. So we have both data. The plus which we see, that is the checking data, and the circle one which we see, that is the training data. So both data we have. Next we have to generate the FIS. So you have already FIS, you design from the app. You can load it from the file workspace, or two methods, grid partition and sub clustering method. So I am going to use the grid partition, and I am going to create a generator fish. So you see here number of membership function. I am going to take 5 for inputs, and I am going to use this. And what will be output type? I am going to take linear for this output type. So from here you can choose for the input how many membership functions will be there, and what will be your output type. Once you did this, and it will generate the FIS. Okay, FIS is generated. And what is the output method? As a back propagation or hybrid method. Back propagation means once it during training it will go back and it will compare, and the error will be minimized. And for how many epochs are you going to run? And right now what is the structure? You can see it from here. Perfect. And when I go here I already selected, and here you can see the structure of it. Right, here is the structure. You can see the structure also here. Okay, once we have loaded that data, then train it now. So for how many epochs are you going to train? 30 epochs if you give, it means 30 full cycle it will run and it will minimize the error. Means 30 full cycles it will run in that case. Okay, just you have to click the train and training will be started here. See, training and testing both are going together. So here you see that in the case of the checking data which we gave here, somewhere it is decreased, that is a validation, and then it is increasing error. This is the error function. Okay, so decreasing then increasing means at epoch number 15 there was a reason of overfitting, then again it is controlled here, the error is increased, right? Okay, once you have trained it, now the testing. So testing, we have already loaded the checking data. Just I am going to select the checking data and test now. And you see that here the perfect, the red one which you see, the this asterisk one, that is the FIS output, and the plus sign which you see, that was the original data. So it is following, means one data is observed one and another one is from the simulated one. So once you have done this, you can check the structure also from here, and if you go here in edit, if you go here in FIS properties membership functions, you can check the membership function as it is which we are designing in that FIS app. In NeuroFuzzy Designer also you will get. So you can modify it also from here if you want. You can modify it, or if you want to add more rules, you can add it from here, more rules also. So automatically you see that 5 rules are added after training. Automatically it will make the rules for you, so you don't have to do anything. Okay, once you design this FIS, next step is to export. Let's say I'm going to export to workspace. I'm going to give a name as a AA. Once we export this, I have a name as a AA here. Now if I give a new data here, so what we will do, to predict evil face, here my FIS system, then inputs, let's say input is 0.25, and let's see that what output will be there, that is 0.5561. Perfect. So both way you can design, either you can use a FIS app, or second way you can design NeuroFuzzy. Apart from that, let me switch here. If you want to design the Simulink, we have blocks available for the Simulink also. So directly we have a fuzzy logic controller blocks also. Let me show you in the Simulink here. It will take a little time to open first time. Okay, it is opening. So meanwhile it is opening, let's discuss about and summarize that what we have done right now, and then we will see a neural network. So we started from the FIS system, and also we discussed that how to convert numeric data as a FIS set using the membership functions. We discussed what is the membership functions also. We saw simple logical system, and we saw fuzzy logical systems also. Simple logical system will have value 0 or 1, but in a fuzzy inference system we will have value will lie between 0 to 1. It can be 0.6, 0.4, 0.5 also. We saw the theoretical parts also, how it works, right? Okay, let me close all this everything, and we will start. Let me close this, all these things which is open. Okay, if I go here in library, in the fuzzy logic here, somewhere it will be here. Here it is. Okay, so you see that we have membership functions available here also. Directly you can design in the Simulink also. If you want to use your FIS system as a controller, just simply add it here in the new model. Here is the controller. It is a fuzzy logic controller with a rule viewer. So here you can view the rule as well. Once it is added here, and provide your FIS system which you designed in the workspace. So let me check it. What is that one? So that is named as AA, right? Double click on this. So always you have to remember how you are providing that. So I have this AA here. Already I added that FIS system from where I got from here, which we designed here as AA, right? So here we can give some inputs. Let's say that I am going to take from sources, I am going to take sine wave from here, and I am going to give this sine wave as an input, so it will act as a controller right now. So here I am going to add this sine wave, and here I am going to provide amplitude, that is 1, so it will vary between -1 to 1. And to display this, I am going to take a display block, and you can use it in a Simulink, and using the Simulink you can deploy this controller in a controllers as well. So when I run this, you can display we can display the output here as well. So we have 30 minutes more. We will see neural network, then we will end this session. So it will compile and it will run. It will take a little time. Let me close this. It will check all the rules, everything is proper or not. So once it is compiled, and we can check the output here as well. Okay, you see that you can visualize the output here, right? And here is the time, for what time are you going to run it. And further, if you want, you can deploy this controller also, and you can design some system to control using this fuzzy logic controller as well. Fine. Okay, next we will see neural network. So in this session we will see introduction to neural network, working for designing neural network, features offered by toolbox, and what is deep learning, advance of neural network also we will see. Okay, previously neural in MATLAB it was named as neural network toolbox. Right now its name is as a deep learning toolbox in MATLAB. So these are some applications like Lund University is there. They designed an artificial neural network to match the heart transplant donors with recipients. So lots of applications are there using neural network for the cancer detection, training stack autoencoders for image classification. So lots of applications are in neural network. The big application which we are going nowadays, they are very latest trending, that is deep learning, right? Like if I have to do some kind of live tracking detection as a controller, if I have to use, lots of applications are there of neural network. So what is a neural network? A neural network is a computational model whose layered structure resembles the network structure of neurons in the brain with layers of connected nodes. So like the neurons which we have in our brain, and the concepts is taken for artificial neural network, same as is how it works in our brain. We have millions of neurons in our brain. Millions and millions of neurons are available in our brain. A neural network can learn from data, so it can be trained to recognize patterns. We use to recognize the patterns. We use to classify data and forecast future events using the neural network. Okay. 3 things to know while designing the neural network: why they matter, how they work, and neural network with the MATLAB, how it works. Okay, so first of all, why do neural network matter? Neural network are especially well suited to perform pattern recognition, to identify and classify objects or signals in speech, vision, and control systems. So if you have this kind of applications, if you design such kind of applications, you can go for the neural network. They can also be used for performing time series prediction and modeling as well. So if you have a time series data, you can use time series data to create a forecasting model as well. And for the deep learning, of course, the simple neural network is called the shallow neural network, which we are going to see. Advanced neural network, that is deep learning. When you increase the layers from 10 to thousands, it will become a deep learning in that case. Okay, deep learning networks can have many layers, even hundreds. Both are machine learning techniques that learns directly from input output data. So if you are using neural network or deep learning, you don't have to extract the features from there. Automatically it will learn, means machine will learn automatically. That's why it is called machine learning. Like in fuzzy logic, we are making rules. In neural network or deep learning, we don't require to make any rules. Just we will give the input, outputs, model, and automatically machine will learn itself. How neural network works? See here, a neural network combines several processing layers using simple elements operating in parallel and inspired by biological nervous system as a human which we have. It consists of an input layer, one or more hidden layers, and output layer. The layers are interconnected by your nodes or neurons. These circles which you see that are nodes, or it is also called neurons, with each layer using the output of the previous layer as its input. So what it will happen here, we will give some inputs. These inputs will have some outputs. Output of this first layer will be input for the next layer. We'll get output from here also, and this output will be an input to the next layer. And during training, it will be a back propagation. Whatever output will come from here, it will go to back to minimize the error, weight and bias. So in every neurons, whatever neurons you see, there a equation will be created something like that. Y is equal to W, X is the input, but and this will be bias B. So weight and bias, this is called the weight. Okay, calculus we say this is the slope, right? And this is the bias. So during training, because of back propagation, this weight and bias will be updated, and on every neurons we will get this kind of equations, mathematical equations. Fine. And developing shallow neural networks with MATLAB. So we have tools and functions available. If you have a big data, you can access big data also in MATLAB. So two ways you can design neural network. You can use app or you can write a code for that. So if you are a beginner, you can start from the apps how to design the neural network. The workflow of neural network in MATLAB. Each neural network application is unique, but developing the network typically follows these steps. First of all, we have to access and prepare your data. Prepare means you have to convert your all data in a matrix for the input and one matrix for the output. Create the neural network, configure the network inputs and outputs, tune the parameters and optimize the performance, train the network. So these are the process: access and prepare data. During the access and preparing the data, we split our data for the training, testing and validation. Okay, then we create the network, configure the network with the input and outputs. Okay, if my output is not coming proper, we optimize the parameters of the neural network, then we train the neural network. After training, we test the network, or you may say we validate the network results also, that the model which is created, it is working on new data or not perfectly. So then you can deploy in a hardware, or you can create a standalone applications also for that data as a .exe file. So let me show you an example of a neural network here, how to design the neural network. So first of all, I am going to clear everything from here. Okay. Let me check if I have some data or not here, then we will discuss about that. Okay, I have a data here. I have a cancer data actually here, which I have here. Here you see that I have this parameters values here like this. So total number of samples which we have here, 216 samples we have in this case. Okay. These are some parameters value on x-axis wise, means vertically which you see, this is the first parameter, this is the second parameter, this is the third parameter, fourth parameter. Okay, and this data I have from medical, and for every samples we have a output. One means patient have a cancer, 0 means patients have no cancer. In this case 1 and 0, so 1 means cancer and 0 means not a cancer. Okay, this kind of data we have here, 1 0 1 0 1 0 s like this. Okay, so 1 means cancer, 0 means not a cancer. This is the first group. with the cancer, and this is a non-cancer one, cancer and non-cancer one. So how we have to create the data? All your inputs will be in a single matrix. Sorry, all your inputs will be in a single matrix like this. You can write your variables as a row wise or as a column wise. In this case, samples are as a column wise and variable names are as a row wise. Okay, and for every sample we have a output as a 0 and 1. So here how it works, this output, so you have to create a output as like this. Means if one is in this group, then patient has a cancer. If one is in this group, then patient have a no cancer. So it is not possible that one will be in the both. Means if a person will have a cancer and non-cancer patient, it's not possible, right? Okay, to design this we can use the app. Simply nf tool you can give the command, or nn tool also you can give the command. You just click from the start. So this is an example of pattern recognition, not a fitting. We have to find out the pattern that if a person has a cancer or not. So I am going to choose this pattern recognition from here. Okay, once we have this, my model will look like this: input, hidden layer, output layer, and the input, output layer, and the hidden layers. Hidden layers can be 1, 2, 4, depends on you how many hidden layers do you want. Number of hidden layers means in this case number of neurons. Now it is asking select the input and the target. So input is X and the target is T. Here you see it shows that inputs are is a 100 into 216 matrix, represent 216 samples of 100 elements. 100 elements you may say, or 100 variables you can say, or 100 inputs you can say. For 100 inputs 216 samples are there, and target is 216, means it represents the 216 samples and 2 elements. 2 elements means a cancer or non-cancer patients, right? Once you have done this, do the next. Here you can split your data for the training, validation, and testing. So as a default I am taking 70% for the training, for validation 15%, testing for the 50%. So what it does, training data will be used for the training, validation will be used to validate our data, to remove the overfitting, to check the overfitting or underfitting, as well as it will run until accuracy will not improve more. Okay, testing will be used to find out the accuracy of the complete system. Okay, once we have splitted this data, next, here you can provide how many number of hidden neurons do you want. I am just providing the default as a 10, or you can provide some different neurons values also. So here it's showing in hidden layer 50 neurons we have. This is the weight and bias. 100 inputs we are giving at a time, and outputs are 2, 0 or 1, right? Next, so it is creating a network for that. First of all, here you see that it is creating a network. So once a network is created, you can train it from here. Okay, training is done. And to check the output, I mean accuracy, just here is the option that plot this confusion chart. So here you see that first confusion chart which you see, that is for the training, this is for the validation, this is for the testing, this is the all confusion matrix. How we read this confusion matrix, let me explain you this. So first here you see the green one which you see diagonally, that is correctly classified, and the red one which you see, that is misclassified. So you may say from the output 1, that were cancers, right? 82 are perfectly classified as a 1, means cancerous person, whatever 82 samples were there. 1 from cancer is misclassified as a non-cancer. Same in this case, 63 from non-cancer are perfectly classified as a non-cancer, 6 are misclassified as a cancer. Output 1, output 2 on x-axis. So what is the plot on x and y-axis? On x-axis we have target classes, on y-axis that is the predicted one from the model. This for the testing and this is for the validation. So you see that validation is 100% in this case. See, 18 from cancerous, it is classified perfectly as a cancers, and to second one, 14 samples from non-cancer, perfectly classified as a non-cancer and zero error, right? Total 100% accuracy. Same for the validation testing, and this is the full final accuracy. 150 samples perfectly classified in the first output and 4 are misclassified in the second output. Same here, 91 from second output is perfectly classified as a second one and 6 are misclassified as a first one in first output. Once you are happy with that, just click the next. If you are not happy with that, you can train it again. You can adjust the network size, means number of neurons, or you can import larger data. As much as large data you have, your model will have a perfect accuracy. So next, and from here, if you want to check the neural network diagram, so this is the diagram from here. If you want to import this complete model in a Simulink, just you will click it and it will be imported in the Simulink. So same model if I have to design in the Simulink, you see here, these are the blocks available here in the Simulink, and you can use these blocks to design the complete model. So better design through app and import in the Simulink. So in Simulink, here we have to provide the input, 100 inputs, and here we will get the output, right? Okay, we were here. Now do the next here, and from here you can generate the code for that. Whatever we did, see, we defined the input, we defined the output here, what kind of function we are using, solver, that is train as that is a scaled conjugate gradient back propagation. To create with 15 neurons, we use pattern net. To find out the pattern net, hidden layer is 15, and this is the function which we are going to use. Further, this is training 70%, this is 15 for the validation and 15% for the testing. To train this, single line command train, this is the my network, this is the input and this is the output. When I run, see, if I run this, same thing I will get, which we did earlier. See, same thing it is happening, and my model will come as a net. So, or what you can do here, from here you can import. There is an option to save results. When I click on this, and I will have my model here as a net, because here this is it was written as a net. So if I go here in workspace of MATLAB, I have this model as a net. This is my predictive model here, that is a net which I have. So this is a predictive model, and what we have to do here, you have to provide that 100 inputs, because in our data we had 100 inputs. Okay, what I am going to do, I am going to predict on first one. So I am going to select this first one, and I am going to create new variable, new numeric array, and this is the input. I am going to provide this input on that model. I am going to predict. So what will I do? Net is my model, simply net here x1, 100 inputs. You will have maybe 10 or 5 less inputs, or maybe you will have more than hundreds. So if I run this, okay, there is some issues. Let me see here what is the issue here. What it says, error, input data size do not match the inputs one size. So it says that there is some issues with that input. So what we have done mistake here, let me check this again na? Okay, maybe it is not getting the 100 one. Let me check in x1 how much do we have here. No, you see there is the issue, right? Our inputs were 100, we are taking 216. This was the error, right? So what we can do, let me delete this one again. I selected the wrong here. We have to select the column, single column from there, right? So I am going to open this, and I am going to select first column here like this. Okay, So we don't, because it is a samples na, row wise it is a sample size, so we have to select like this. Okay, I'm going to create a new data set for that, new numeric array, and we have this x1 here. Now we can predict. So you see that two outputs we got here, 0.9378 and 0.0622, but actually we had to get 0 or 1. So in this case, which is near to 1, that is the output. So it means third sample, the sample which I provided as an input, it says that based on that data, the patient is cancerous, he has a cancer. So here you see, to find out the 0 1, simply you can do find answer greater than 0.5. If it is greater than 0.5, it will give me a value 1. So here we have, in this case, right, we have it is greater than 1. Or simply we can use like this, just predict this, and simply instead of using find, just simply use like this. So we will get 1 or 0. So 1 was the first group with the cancerous one, and 0 was with the non-cancerous one, right? So this was about the neural network, how you can design the neural network. So if you are a beginner, you can start from NN tool or NF tool, whatever you have. You can use this NN tool also, or just go here in the app. From the app, this is part of machine and deep learning. So here this is a fitting one, fitting example. If you have to do fitting, just click on the fitting, do the next, and just provide the inputs from here. Simply import the inputs you will have in your workspace, do the next, and split your data for the training, testing, validation. Next, provide the number of hidden neurons, do the next, and train this. What kind of solver are you going to choose? You can choose it from here. Once it is trained, you can plot the histogram of as well, or you can plot the regressions also of that as well. So if I plot the regression of this is a fitting one example which I am showing you. This is a fitting one. That was a pattern recognition, means classifying. This is a fitting one. So you see that in this case training is 0.89, means it is near to 1. If it is near to 1, it is perfect. If it is not near to 1, it is less. So regression value lies between 0 to 1. It has to be near to 1. And this is the overall regression for the fitting, for the training, and for the testing. All three. Training, testing, and validation. Okay. So like this you can design neural network. Right now, if you have any questions, you can ask me. Or something you didn't get, I can repeat it. If you have any questions, you can ask me.